Okay. What do we got here? So this is the first one. So I did listen in on some questions regarding whether we could use like the built-in inverse functions in MATLAB. You can, but just make sure that you understand this is doing something a little different than the inverse. So the idea, I can show you how this is a little bit different. If we take the inverse, let's say we do matrix equals magic 3. That's what the magic 3 looks like. And then we want to find the inverse of that matrix. Okay, so that's our code's going to do that. But here's where our code differs. If we have, like, let's say our matrix is, let's concatenate a column vector with 3 elements. So that's matrix. And then we'll do 1, 2, 3. So it's like a 3 by 4. So this is not going to work. Hold on. Let's do inverse of matrix again. Our code will not do this. Instead, it'll return an empty array. So we'll need to manually code that part instead of actually doing this, spitting out an error. Okay. I'm gonna reach out and I'm gonna ask for some help with this. We'll want to do 2 things. Either we'll need to spit out an empty array if one of 2 things happens. So this will be an OR. If A isn't square, or if the determinant of A is 0, it's like between 0 and between -10 to the power of -10 or +10 to the negative power of 10. So this is like, or the determinant of A is between -10 to the power of 10 and that. Let's try the first one. What statement do we need to say A is not square? Here's a hint up here. Can anybody tell me? Or type it in the chat.
Row not equal to column.
Row call. And how do I say not equal?
Squiggly line equal.
Tilde equals is not equals. Okay. Or determinant. Let's do this in 2 chunks. So we'll use right in this one. So I'll just like do this one out for you. I just want to make sure that people understand this is not a permissible comparison in MATLAB. You can't do like a something less than something less than something. MATLAB only does comparisons between 2 things at once. That's the only thing it understands. You will need to break this up into something like this. Okay, pop quiz. Is this, I'll need another thing between this and between these 2 numbers. Is it going to be, this is a -10. Is this do I need an and or an or here? Between here. Seeing some ands? Mm-hmm. It has to be between those 2. Because if we had, say, 2, well, that says, like, basically any number is going to satisfy one of those conditions, but it has to satisfy both to be within a certain margin of 0. The determinant, we want to be roughly 0 for this to return an error. So to recap, this is the not square condition, like we did here, that caused an issue. And this one is if your determinant is 0. So that's like, or roughly 0 in this case, within a certain tolerance. That's what breaks our inverse function. But if it's not, there's a couple ways to do this. Someone say their favorite way of calculating the inverse. You can see a to the power of -1. Okay. And let's do a semicolon. Let's test this out. Always a good thing to do. Mat inverse. Oh, we conveniently have a matrix ready to go. That makes sense? Because it is not square. Now let's do matrix equals magic 3 one more time. So this should work. Matrix, no, let's not do matrix. Let's do B equals mat inverse of matrix. Let's check to make sure that's the right thing. Inverse of matrix. Same thing? Same thing. Perfect. Okay. Any lingering questions before we move on to the next one? What? Once? Going twice. Newton's method. And yeah, clear this out. Okay. I need 5 seconds to set up my pen here. Some of you may be familiar with the Newton/bisection method, but I'll draw it out for the people who aren't. And just so you, if you're curious about why there's 2 methods we're teaching, why one's not necessarily better than the other, is one of them is faster but more unstable, while the other one is slower but more stable. And I can explain what that means, but let me just draw it out. So my Newton method goes like this. You have some function, it doesn't matter what function, and we'll start with a guess. Here is our destination. Destination. We want to get from here all the way to here. We're trying to find the root. And the way we'll do that is we'll take this dot and then we'll shoot down along the tangent line down to the x-axis, and we'll see where it hits the x-axis. Okay, this is going to be our next guess. This is our initial guess, x naught, and this is like our new x naught. And then we're going to continue this process until we get satisfactorily close to our root. By that I mean within the tolerance. That's Newton's method. New method. So we're given our R, which is this is going to be an array eventually, but it starts with x naught. And we're going to chain together into an array like a bunch of different guesses. It's going to get closer and closer to our destination. So this will be like, this could be like 3, 2.5, 2.7, no, wrong way, 2.25, etc. And this one's going to be the error. How close are we to 0? This could be like, I don't know, 3, 1.5, etc. That's what this line is. Oh, something in the chat. Oh, never mind. Okay. That's this first initial part. We'll want to run this 100 times because, well, if we have an infinite loop, we don't want it to be infinite. We want it to stop at some point. So we'll tell MATLAB, hey, you did your best. It's been 100 iterations. You can stop now. You can give up. So that's given how fast the Newton's method is, it's probably going to stop way before 100 iterations. That might not be the case with the bisection method, though, because bisection method's slower. So if we are within a certain, let's say this is our error, right? This is our function. Here's like the x-axis, and then here's our function, and this is our error, and that's like less than tolerance. It's like this is the tolerance. Then we're good. And then we just break the function and return our R, return our E. Now, help me out with this next part. How are we going to get the new root? So there's 2 parts to this. Put the new root into R. So, well, 3 parts actually. Find new root, put the new root into R, and put the corresponding error into E. Let's put this into one single line. New root, how do we find that? I'm going to start you guys off. X naught, because we want to like rename X naught to this new X naught. X naught. What do you guys think? What should we do? I'll give you guys a hint. Point slope formula. Give me more specific. While you're doing that, I'm gonna draw.
So what I did is, I'm pretty sure, yeah.
I'll write this like x naught prime kind of.
Yeah, so you're given a point and you're given the slope with df. And then you need to find where y is 0, which is the x-intercept. You need to find x when y is 0. So you have all your variables and you just solve for, you just like put the point slope formula in terms of x.
So we know f of x naught is this part. I'm going to explain geometrically as well. So we have some intuition as to why this is other than formulaic. F of x naught, and this is going to be x naught minus, like this is kind of like f of x naught minus 0, and this is x naught minus x naught prime. And then I'll need some extra space over here. I'm going to delete this part. Get rid of the meth over here. And then point slope formula, we're going to do slope df x naught. Let me see if I remember this. F of x naught minus 0 over x naught minus x naught prime. And then rearranging this is just going to be x naught prime equals x naught plus f of x naught over df of x naught. Do the units work out? Yeah. Rise over run equals run. Yeah. Someone can check my work on that, but I'm pretty sure that's right. Okay, how do we code this? df at x naught, that's the original x naught, by the way, over, nope, this is wrong. df x naught. Okay, this is a structure that you may be familiar with already. How do we put this new x naught into our root, into our R array? Concatenation. That's my hint. That's right. And what about down here? Is it E x naught? Angela's close. We'll need something else tacked onto there. Yeah, absolute value. In this case, it doesn't matter because we're already positive, but we are going to want to take a positive error. Because what happens if this thing's negative, right? If the error is negative, like -2, but it's not within like a certain range of 0, we're going to break this thing prematurely. And we want to be a little bit careful of that. So absolute error. Okay, I think I took this one. But one more thing we need to do always, test it out. I've put all of these files in the current folder, by the way, but just make sure that everything is there, so you don't get something like undefined function for type double. What do we got? My Newton, not Newton. My Newton. Oh, okay. Let's do some things first. Let's make someone give me a function. An easy one, please. X to the power of, let's see, which is, should we do x to the power of 2 or x to the power of 3? Does it work with x to the power of 2? I'm pretty sure it does. Like, let's try x to the power of, let's not do x to the power of -1. That doesn't have any roots. It's like an asymptote like that. Unless we wanted to do like -1 or something. Let's keep it simple. Let's do x to the power of 2. No, we can do like all of these if we wanted, depending on how much time we have. Okay, I'm making an anonymous function, by the way. So this is how you do it. So df is a function that takes an input x and spits out 2 times x. We have our df. X naught, where do we want to start? Let's do, I don't know, 2, and tolerance equals 10 to the power of -10. Okay. Let's do r comma e of f my Newton f comma df comma x naught comma tall. Here we go. Oh, really? Oh, that's interesting. What happened here? So what does this mean? Oh, my mistake. This is a minus sign. This thing blew up because of that one. Thank you very much. Okay, from the top. Okay, didn't take nearly as long. Okay, we started at 2, we shot down, and then we landed at 1. Then we landed at 0.5, and it halved every single time. And then we got to 0, or within fairly good tolerance of 0. Let's try some other ones. D, let's do this. F equals at x, x to the power of 3, and df equals at x, 3 times x to the power of 2. Trying to do calculus in my mind. This is not a good idea. Okay, takes roughly about the same time. And that's Newton's method. All right, thank you for the help with that. I'm clearing in 3, 2, and 1. Any questions on Newton's method before we get to bisection? Okay, similar structure. We have our new guess, and we have the error of that. Yeah, the error of our new guess. Or I guess yeah. Okay. Bisection method. Visually, how do we that sounds dumb. Visually, how do we visualize this? All right, here's a function. We have 2 x coordinates. Here's your x, here's your y, here's your a, here's your b. A is the left x, b is the right x. And here's going to be f of b and f of a. And the idea behind this is we want to have these be different signs because we're going to kind of zero in, like it's like the walls are closing in. Indiana Jones, I don't know what movie, but we're going to want to take the midpoint as our new guess, and then, okay, where's the root? Is it here? Yes. Is it here? No. We're going to go over here and then make this our new guess. So we're going to have this, we're going to rerun this with our new A and B. And we're going to keep doing that until we get within a certain tolerance. Okay. So with that knowledge, there's 2 things going on here. There's 2 else ifs. And that's to do with these 2 regions. I'm going to number them 1 and 2. Is it to the left? Wait, midpoint, so that it's the left new. Oh, sorry. This is 2 and this is 1. So this is like if it's in the right region. So if the sign of our midpoint, so that's, I'll write f of a plus b over 2. Whenever you see like 2 things added over 2, that's the average or the midpoint. So if the sign of our midpoint, I'm going to write midpoint, is the same as the sign of our left point, which in this case it's not, then that means that the root is in the left or right region. It's going to be the right region. So we're in region 2 over here. So let's reassign, let's call A, B, A plus B over 2. Is that right? Yeah, it's the opposite of what we're doing in the other one. So what's this going to be? What's going to be equal to the midpoint? Okay, once. It's going to be B. And that's going to be this case I've drawn over here. I mean, I'm not sure if I need to have participation for this next part. It's just concatenation, once again. But instead of doing the new root, so to speak, it's just going to be this one up here, the midpoint. Like that. And we'll do something similar here. Yeah. And then this is going to be similar as well. Concatenate the new error like so. Just quick disclaimer, by the way, if I make any errors, refer to the RAR file with the solutions on B courses as your primary reference, because I can and will and do make mistakes. Nobody is perfect. But let's assume we are perfect and let's test this out. And if MATLAB proves us wrong, and we are indeed flawed human beings, then let's see, what A and B do we want? Last one we tested out was x to the power of 3. So let's go with -1 as our A, and then B could be positive. No, that's dumb. Why is this dumb? Why should we do this? Why is this a not very interesting bisection start? Yeah, exactly. We're bracketing it, and then the midpoint is already within tolerance. Here's an interesting one that we could do, though. Let's do B is 1/2. So that way it's like a third of the way to the right. I'm not sure that made sense. Let's do not my Newton, but my bisection, and then we'll run that with the new, with the A and B. And I think we don't need to specify anything else. Bisection, F, we specified already. A and B, we just specified. And tolerance, we specified in the previous part. Okay. Seems pretty solid. Wait a minute, does that make sense? -0.00. Okay, yeah, I guess it makes sense because we're cubing this. I was thinking like this doesn't look within 10 to the power of -10, but if we're cubing it, then the error is going to be a lot less than that. All right, that's it for this one. And there is one other one, but I think this next one is not too. I didn't actually make skeleton code for this one. I think it's pretty by the book. It's from the PDF. You can read up on complex numbers if you want, but I think you don't need too much background to kind of do this problem. You look at the Mandelbrot set if you're like Julia sets, Mandelbrot set, complex numbers, but a bunch of buzzwords if you're interested in this kind of stuff. Mandelbrot sets, like you can like look up stuff on YouTube about that. It's like hypnotizing. But I'll stop the share now if no one has questions. We can go over the quiz if you guys want. Oh, I actually have that up right now. Okay, let's see. Here we go. Let's do previous quiz again. Okay, who had questions on the quiz? Let's just do a typical Q&A format on this instead of going through each one. I think Ava, right? Did you have questions on any of these?
I had questions on a lot of them, to be honest.
Did you? If there's just a lot of them, then I pick a few.
Okay.
Not like the majority of the questions. Like I think that would be the purpose. But because like I think if you search in files, you'll find the lecture slides. I mean, question 1 is D. I mean, that's already in the lecture.
Mm-hmm.
So this one you
So-
can probably test out in like as well. A lot of these actually.
So I guess question 11.
Correct matrix form of A. Okay. What was your confusion with this one?
Well, I'm just a little,
Confuzzled?
yeah, sorry. And
It's a little different than the previous problem that kind of looks like this. You have like this is a constant to my understanding. It's a lot of, I mean, it's basically a vector of constants. It doesn't have any like unknowns. Well, I mean, I guess these could be, it doesn't specify, but here's how they want you to think of it. Like this is your like answer in a way. And it equals this part and this part. And you're just looking at this chunk over here with like your A's, your A
oh
naughts.
wait, no, never mind. I get it now.
Okay.
Yeah. Okay, so in that case it would be I think it would be A, right?
I think so, yeah.
Yeah. Okay.
Yeah, definitely not C or D. Because I mean you take that if they asked for A beta,
Mhm.
then it would be either C or D. So yeah, I think that's pretty straightforward once you know what you're doing. Okay. Okay. That part's pretty short. Are there any other questions on the quiz, or should I just open this up to general questions?
Could you do question 10 too?
10, sure. Gotcha. Let's go through it. A through C. Let's start with the easy one. Let's do C first. Can this be written as yada 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 yada?
It kind of looks like it can, but I'm not confident.
What would make you confident?
Well, I'm just with the multiplication. I'm between the matrices. I feel like that would mess things up.
You can multiply two different matrices so long as you obey the rules. Like if this is M, if this is M long and M tall, those match up. Like it's this dimension and this dimension need to match up.
Okay.
Yeah, try writing this out and then see if that makes sense. If
Yeah.
the-
Okay.
assuming you can do the next problem, you can probably like reason out like, oh, how do you turn this into like matrices like this?
Yeah. Okay. All right. Thank you.
No exact solution. I think like A and B are related. Are you familiar with overdetermined and undetermined?
No.
Okay, let's go over it then. So there's like three types of problems in these I don't know what these are called. There's like matrix, like linear systems. You have situations where you have you have an A and you have a B. And your A is going to be one of three things. How do I want to organize this? Case 1, A is square. Square, like 3 by 3. And then it's going to be something like 1, 2, 3, 4, 5, 6, 0, 0, 0. Case 2 is the overdetermined, over det. This is where you have like more equations than unknowns. So like equations greater than unknowns. It's like you have more information than you need. So like you might not get a solution out of this because you have like so many constraints that like no possible solution satisfies those constraints. So that's like if you have, I'll just like write ones, but like this is like to show the size of it. Here's one. Here's like 4 equations, but only 3 unknowns. So that you can multiply this out, like A naught, A1, A2. Like this is valid matrix multiplication. But the idea behind a problem like this is you might not get a combination of A naught, A1, A2 that satisfies all of these. Well, in this case, you probably do, but like in the general case, you probably don't.
Okay.
And then obviously the one we have left is underdetermined. Under det.
Yeah, I understand that. Okay.
To clear that. Yeah. So I assume you can figure out what answer that is.
Yeah.
Let's see, did I miss anything in the chat? Don't think so. Let's stop sharing then. Okay, I'll open up to general questions then. And for people who just joined, the reason Jose is not here is because there's a career fair for like today, and he will be talking to some very important people until 7 o'clock, I think. He might join us later. But let me stop the recording, by the way, if we're